Today we have our lecture for Chapter 3, starting with 3.1. What are radians? Suppose you have a circle. Every circle has a center and a length called the radius. Now the radius of a circle is directly related to the concept of a radian. That's why they have similar names. If you were to take this length of segment, the length of the radius, and bring it around as a curve. So suppose this segment right here is congruent to this curvy segment. They have the same length. Then the angle formed by these two radii intercepting this arc that has the same length as the radius, this angle right here, theta, is equal to 1 radian. So if you were to continue to go around the circle, you will notice that you have 1 radian, 2 radian, 3 radians, 4 radians, 5 radians, 6 radians, and then you have this fraction of a radian that's roughly around 0.28 radians. Where am I getting that number from? Well, how many radians are there in one circle? 6.28 is approximately 2 pi. Think about the formula for a circumference. The circumference of a circle is 2 pi r. That means that the circumference takes 2 pi radius lengths to go all around. What that means is that there are 2 pi radians in a circle. Here's your big conversion, that 2 pi radians is the same thing as 360 degrees. Think of this as converting back and forth between Fahrenheit and degrees. Fahrenheit degrees and Celsius degrees. Fahrenheit degrees and Celsius degrees both measure the exact same thing, but just with different numbers. And so in the same way, radians and degrees for a circle both measure an angle, but with different numbers. Now, 2 pi to 360 can be reduced to an easier to work with ratio, right? If you divide both of these by 2, you'll get that pi radians is the same thing as 180 degrees. And this is the ratio that we use to convert going back and forth between radians and degrees, or degrees and radians. So, for example, if you have 15 degrees and you want to convert 15 degrees to radians, you simply multiply by the unit multiplier. There are 180 degrees in 1 radian. So 15 goes into 180 how many times? 12 times. So this reduces to 1/12 of a radian. I wrote this down wrong. This is pi radians. Here we go. Sorry about that. If you were confused, I have corrected this. 15 degrees times pi radians over 180 degrees is equal to pi 12th of a radian. Much better, more accurate. There you go. Now you actually don't even have to write the word radian. It will be assumed that if you do not have a degree symbol, you mean radians. All right? So if you see something like this, this is taking the sine of 15 degrees. But if you see this, this is taking the sign of 15 radians, okay? There is no degree symbol, which means that this is 15 radians. Now that's not a number we use commonly, but if you don't have the degree symbol, you are meaning radians. Of course, the sine of 15 degrees would equal the sine of pi over 12 radians, because 15 degrees is the same thing as pi over 12 radians. So now let's look at some MyOpen math problems. So here we have a MyOpen math problem, question number 3. We need to convert negative 160 to radians. So how do we do that? Well, you just take your negative 160 degrees and multiply it by your unit conversion. There are pi radians in 180 degrees. (16 over 18 reduces to 8 over 9. So this reduces to a negative 8 pi over 9. There you go. Notice that we don't do a decimal approximation. We reduce to an exact answer. Question number 4. Convert 224 degrees to radians, give the exact value. Okay, so again, we're going to have 224 degrees. Multiply that by the unit multiplier. (224 over 180). What is that reduced to? Both 224 and 180 are divisible by 4. That's their greatest common factor. So 224 divided by 4 is 56. And 180 divided by 4 is 45. And we have a fully simplified fraction. Okay, next problem. Question number 5. 75 degrees, 54 minutes to radians. Give the exact value. Okay, that's a little bit harder. So what we're going to do is start by converting 75 degrees, 54 minutes into a mixed number. From there, we can reduce, if possible. Sometimes you can't reduce the minutes. In this case, you can. 54 and 60 are both divisible by 6. Next, convert the mixed number into an improper fraction. 75 times 10 is 750 plus 9. Now we have 759 over 10 degrees. Next, use the unit multiplier that there are pi radians per 180 degrees. Next, we try to figure out how to reduce this. 759 is divisible by 3. It's not divisible by 9 or 2 or 5, and so that's as far as I'm going to go as far as reducing. And then of course if I divide 180 by 3 I get 60. 60 times 10 is 600. And so I have now reduced to 253 pi over 600. Now going back the other way, let's look at question 7. If you have 38 pi over 15 and you want to change from radians to degrees, you use the unit multiplier again, but this time we're converting 2 degrees. So whatever you're converting to goes up in the numerator for your unit conversion. You'll notice that the pi's are going to completely cancel. 180 divided by 150 reduces to, these are both divisible by 30, so that would be 6 over 5. So now we just have 6 times 38, which is 228 over 5. So what I've done is I've reduced 180 over 150 to 6 over 5 multiplied 6 times 38, and this is degrees. Now, of course, you can take this number and divide it by 5 and get something without rounding. This is going to be 45.6 degrees. So I'm not quite sure if the answer is supposed to be rounded or not. If this were a problem with rounding, I would err on the side of not rounding. If you see directions that say to round, then round. But in general, unless you have a word problem or directions that tell you to round, don't round. Okay. So the same thing is true for any of these. Now, when you get to question number 9, you would do the same sort of thing. You just take, you don't have a pi this time, but you have negative 1.7 times, we're converting to degrees, so this would be 180 degrees over pi. Now, there's no pi in the negative 1.7 that will cancel with this pi. So, your answer is going to be a little funky. If you multiply these two together, you get negative 306 over pi degrees. Now you can enter that, and then if it doesn't like that answer, then I would go ahead and do the decimal approximation for this. The good thing is when you submit the question, if you get it wrong, you can attempt a new version of the question, and then you know how the answer is supposed to look. And you don't have to redo the entire homework. You can just fix individual problems. This is roughly negative 97.4 degrees. Don't drop the negative as you go along. Make sure you maintain it. Okay, so then when you get to a question like number 10, how do you find the sine, cosine, tangent, and secant of negative 3 pi fourths? Well, 3.1 teaches you a method on page 103. And you can use this method. This method is not the method I use because I know the unit circle. And I'm about to teach you the unit circle. So you have the choice. As you're doing 10 through 13, you can either do it this way or you can use the unit circle. It doesn't matter. All that you have to do is come to the correct answer. But let me show you how this one is done. What you would do is you would take negative 3 pi fourths. And by the way, if you have radians that have a pi, the fastest way to convert is just to replace the pi with 180 degrees. If you understand this, what happens is that the pi in the denominator will cancel with the pi in the numerator, and so this is the same thing. So what's 3/4 of 180? That's 135, right? So then for each of these problems, you would revert back to what you did in chapter 2. How do you find the sine of negative 135? Well, first you would want to draw this on the unit circle. Here's your initial side. The vertex is located here, and then your terminal side is down here because we are going in a negative direction. So that's negative 135. Now from that, you can see that your sine and cosine values will be negative because you are in the third quadrant. Because you are in the third quadrant, you have a negative sine, you have a negative cosine, therefore you also have a negative secant, but tangent is going to be positive. Tangent is positive in the first and the third quadrants because sine and cosine have the same signs. That is, they're both positive here, they're both negative here. A positive divided by a positive is a positive, a negative divided by a negative is a positive, and that's why tangent is positive in the third quadrant. So once you determine the signs, then you can use the reference triangle. So remember, you take a perpendicular from a point on the terminal side, you drop that perpendicular to the x-axis. This ends up being a 45, 45, 90 triangle. And you can see then you have a 1 to 1 to root 2 ratio. If you were to find the sine of 45 degrees, in this context, the sine of 45 degrees is equal to opposite over hypotenuse. So 1 over root 2, which will simplify to root 2 over 2. This is the longest way ever to get to your answer. You really do not want to stay with this. But it's good to understand how this works because you do want to understand where all the values on the unit circle are coming from. To memorize the unit circle, you have to have an understanding of how the unit circle originated. And the unit circle originated from these reference triangles, the 30, 60, 90 triangle and the 45, 45, 90 triangle. Okay, so if the sine of 45 is root 2 over 2, that means the sine of negative 135 is a negative root 2 over 2. It's going to have the same number, but the sign could be different. Likewise, cosine is going to be the same. Tangent is sine over cosine, so tangent is 1. And then secant is the reciprocal of cosine, so the reciprocal of 1 over root 2 is just a plain old root 2, but this is negative. Okay, so what I've done here is I've reviewed for you how to do a problem from chapter 2. Now you may ask, okay, what is the fast and easy way to do this from the unit circle? Well, let me introduce the unit circle to you first. But before I do that, I just have a couple more problems I want to go over from 3.1. So I want to do 92 and 94 for you to help you with your word problems, and then I'll jump into 3.3. Okay, so from page 106 of your book, number 92. Through how many radians does the minute hand on a clock rotate in 12 hours and in 3 hours? Okay, so let's start with 12 hours. The minute hand on the clock rotates around the clock once every hour, okay? So the minute hand goes once around the entire clock every 60 minutes or every 1 hour. That's what a minute hand does. You know this. Going around the clock entirely once is the same thing as going 2 pi radians per 60 minutes or per 1 hour. So if you make the conclusion that the minute hand goes through 2 pi radians each hour, then you can conclude quite easily that in 12 hours, the minute hand goes through 24 pi radians. So 24 pi radians per 12 hours and 6 pi per 3 hours. This is not that complicated. You just had to revert back to some intuition about what a minute hand does. Okay, pretty simple stuff. Now let's do number 94. Number 94 is a pulley. You don't have to have much experience with pulleys in order to do this. A circular pulley is rotating about its center. I should hope so. That's what circular pulleys do. Through how many radians does it turn in 8 rotations? 8 rotations. How many radians are in 1 rotation? 1 rotation is equal to 2 pi radians. Therefore, 8 rotations is equal to 16 pi radians. And then 30 rotations, this is part B. 30 rotations will pass through 60 pi radians. So these problems are not complicated, but sometimes they can give students some anxiety. So once you see them, you go, oh yeah, that's easy. And it is. All right, so now we're going to go on to the unit circle. To explain the unit circle, I've decided to start with the blank one. Okay, so this so far should make sense to you. You should have an intuition about how to divide up a circle in degrees. You know a 0-degree angle. You know a 90-degree angle. You have 180 degrees. You're splitting up 360 degrees into fractions. Okay? Now, I want to give you an intuition as to how to do this with radians. And actually, now, how I do it may not be how you do it, but this is how I do it. What I consider is that I think about quesadillas. Now, when I make quesadillas, I take a tortilla and I fold it in half. So my quesadilla looks the same as 1/2 of a circle. Actually, I don't make quesadillas anymore for myself, sadly, because I don't eat gluten or dairy. But my children do. So here's my quesadilla. Now I'm going to call my quesadilla a pie. So I'm going to live in a world where all quesadillas remind me of pies. There you go. So this is 1 pie. And I should already know that 180 degrees is 1 pie. So now I'm just going to think about fractions with food. Because somehow, when we think about fractions with food, it's less stressful. Think about dividing up a pizza. In this case, think about dividing up a quesadilla. Okay, so what would be 1/2 a pie? 1/2 a pie would be right here. If I were to split the quesadilla in half, this is 1/2 of a pie. And what does 1/4 of a quesadilla look like? Here's 1/4 of a pie. So 3/4 would be right here. And so here I'm thinking in terms of 1/2. I'm thinking in terms of 1/4, 2/4, 3/4, 4/4. Now I can also think in terms of 1/6. If I wanted to have 1/6 of a quesadilla, I would be cutting it right here. If I wanted to have 5/6 of a quesadilla, I would be cutting it way over here. And of course, if you have 2/6 of a quesadilla, 2/6 is the same as pi/3. You can think in terms of thirds. I have 1/3 of a quesadilla, 2/3 of a quesadilla. Here's my 2/3. So this is how I think about pi. And once you internalize this, oh yeah, this is what a pie looks like. Sure, I know what 1/2 of a pie looks like. I know what 1/4 of a pie looks like. I know what 1/6 of a pie looks like. Look at it as a physical object, like food, and you can break it up in your head. Okay, so now we get to improper fractions, and you do have to have some understanding of improper fractions. So if I have 7 pi/6, I'm going to think, okay, well that's 1 1/6, right? 7 pi/6 is 1 1/6 pi. So I have my full 1 pi plus another 1/6 pi. Or if I had 5 pi fourths, 5 pi fourths is 1 1/4 of a pi. So here's my 1 pi, here's my 1/4. So 1 1/4 brings me all the way here. That's 5 pi fourths. Then this one right here would be 4 pi thirds, because this is 1 1/3 of a pi. So now I'm coming all the way over here. And then of course this is 1 1/2, and 1 1/2 pi's is 3 pi halves. So you get the idea. This one then would be 5 pi thirds. So if you can think in terms of radians, it will save you a lot of trouble, okay? It's like a foreign language. If you have to convert amarillo to yellow every time you want to think about yellow in Spanish, it's going to slow down your thought process. But if you can just look at the color yellow and think amarillo, then you've actually got to a closer access of the language. And the same thing is true with radians and degrees. You want to start thinking in terms of pi. Think in terms of these fractions. So what's this one? Well, this is 1 plus 3/4 of a pi. So that would be 7 pi fourths. And this one right here, this is 1 plus 5/6, and that's 11 pi sixths. So the more you can think in terms of these fractions, the better. Okay, so that is thinking of the unit circle in terms of radians. Now let's talk about the values. So the first thing you want to be able to do is you want to be able to line up numbers from least to greatest. And you should be able to do that. These numbers can be lined up by a kindergartner or a first grader. Okay, least to greatest. Now, let's take the square root of each of these. Square root of 0, square root of 1, we're still going least to greatest. Square root of 2, square root of 3, and the square root of 4. Okay, so that's still least to greatest. Now also, let's go divide each of these by 2. Least to greatest. So here I've divided each of those numbers by 2 and lined them up from least to greatest. And now I'm going to simplify each of these numbers. So square root of 0 over 2 is 0. This is 1/2. Okay, so now I've simplified each of these numbers. So you want to have it in your head that these numbers are from least to greatest. 0, 1/2, root 2 over 2, root 3 over 2, and 2. And these are the only numbers, these and their opposites, that show up on the unit circle. So how do you label each of these? Think of y in terms of height, right? Y is going from 0 up to 1. 0 to 1. So your lowest height is down here. Then your next highest height is 1/2. Then your next is root 2 over 2. Then your next is root 3 over 2. And then this is not supposed to be a 2. This is supposed to be a 1. So if you were questioning my math, thank you. That's a 1. Then the next highest is 1. Okay? So you have on your y-axis 1, root 3 over 2, root 2 over 2, and 1/2. Okay, going back to the blank unit circle, what I want to do now is fill in the values for each of these points from memory. I'm going to start with the y values. The lowest y value number is 0. As I start moving up, what is the next value? 1/2. I'm moving up from least to greatest. The next value is root 2 over 2, from least to greatest. The next value after root 2 over 2 is root 3 over 2 and then 1. And once you get to 1, you're going to start going back down again. So I'll fill these in now. So here we are going back down. We've got 1, then going down to root 3 over 2, then root 2 over 2, then 1/2, then 0. And then you sink down into the negative numbers. So here you're at negative 1/2, negative root 2 over 2, negative root 3 over 2, negative 1. And then you come back up, negative root 3 over 2, negative root 2 over 2, negative 1/2, and back to 0. So those are all of the y values. Now, I can't make you memorize the unit circle for this course. It's an online course. But I tell you what, it will make a very big difference to your trig experience if you have this thing memorized or if you don't. You can have this out in front of you, but if you have it memorized and you can go to the answers immediately, that would be the way to do it. All right, let me show you the full unit circle now. Here's the full unit circle. You can find this image or one that's similar to it in a Google image search. Just type in unit circle. There's also one in your book. It is on page 117. So if you go to page 117 in your book, you will find the unit circle. But it's a whole lot better to have it out beside you when you're doing your work rather than to have to flip back. Also, that one is really small. So if you have a nice big one the size of a full sheet of paper, then it's really handy. So let's look at this. We have the y values starting at 0, going up to 1/2, root 2 over 2, root 3 over 2, 1. Starting to go back down again, root 3 over 2, root 2 over 2, 1/2, 0. Now we're sinking down low, negative 1/2. Further down, negative root 2 over 2. Further down, negative root 3 over 2. All the way down, negative 1, and then we come back up again. So this is how I memorized it. I can see this as like a physical location of height and width. Let's think about the x values. X values, the furthest to the left is negative 1. The furthest to the right is positive 1. So as you move from left to right, this is actually even more intuitive. It's going to line up like numbers on a number line. Negative 1 is the least value. What's the next least value? Negative root 3 over 2. What's the next least value? Negative root 2 over 2. What's the next least value? Negative 1/2. See, these are numbers on the number line. Then I have 0. Then I am back again to positive 1/2. Then positive root 2 over 2. Then positive root 3 over 2, and then 1. So I'm going from least to greatest, negative 1, all the way to positive 1 on the x-axis. The x values correspond to cosine values. The y values correspond to sine values. So now let's clear this and use the unit circle for my open math. My open math. Let's go back here. We had theta is equal to negative 3 pi fourths. So we just need to find negative 3 pi fourths on the unit circle. Wrong tab. Here we go. Negative 3 pi fourths. How do we get to negative 3 pi fourths? We're going to start here, and we're going to move backwards this way. And there we have negative 3 pi fourths, which is coterminal with 5 pi fourths. When we were finding coterminal angles with degrees, we were adding and subtracting multiples of 360. Now we're adding and subtracting multiples of 2 pi. Okay, now let's look at the values here. We have a cosine value of negative root 2 over 2 and a sine value of negative root 2 over 2. Then the tangent value would have to be sine divided by cosine, which is 1. All those values that we came to before, we can get immediately from the unit circle. Let's do another problem. Aha, question number 13. Now you have all sorts of different angles. It would take you forever to come up with triangles for each of these. So what we want to do is locate each of these on the unit circle. So for starters, we need pi thirds. So here we come over, here's 0, pi thirds is right here. There's your pi thirds. Cosine is 1/2. Sine is √3/2. So we come back over here. Sine of pi thirds is what now? √3/2. Next, cosine of -3 pi halves. Come back to the unit circle. To get to -3 pi halves, I start here at 0 and I go backwards 1½ pi's. -3 pi halves is coterminal with pi halves. The cosine value is 0. The sine value is 1. So coming back here, if I need the cosine value, that's 0. Now I tend to use my arms. I literally move my arms around a circle. Like there's this giant imaginary circle in front of me. And my arms move to the right and the left with cosine, and they move up and down with sine, and that's how I have internalized the unit circle. So I can, in my mind, reach up and grab any of these values very quickly. Tangent of pi halves. Well, when I'm thinking about the unit circle, I'm thinking about pi halves being right here. And then the sine value is 1, and the cosine value is 0. So 1 divided by 0 is undefined. Or in this case, instead of writing undefined, they tell you to write DNE. DNE. So I should have written that. 7 pi fourths. 7 pi fourths is way down here. I know my cosine value is √2/2, and my sine value is -√2/2. So if I need to find secant, that's going to be the reciprocal of cosine, so that is going to be a √2. And that's how you do this, all from the unit circle. So as you work through this problem again and again and again, as many times as you need to until you reach fluency with the unit circle, then I hope you start to internalize it as I have done. Or drill yourself and memorize it like you would have a high school student get quizzed on it every single day, like my teacher did. Okay, now let's move down to question 14. So in order to do this problem, what we have to do is figure out what is theta in degrees. Okay, so if you start here and you go all the way around, this is 180 plus another 60, so that is 240 degrees. Now what is that in radians? Well, we have a pi, and then we have a third of a pi, which is 4 pi thirds. So you have your 4 pi thirds. 4 pi thirds. This is not cooperating. That's supposed to be 4 pi thirds. Okay, what is the x-coordinate at P and what is the y-coordinate at P? Go to the unit circle, or if you've already memorized it, this is -1/2 for the x-coordinate, because it's the first one to the left from 0. And the y-coordinate is -√3/2, because it is the furthest down except for -1. But you can go and look at the unit circle and see the same thing. You can see the x and the y coordinates right here. -1/2, -√3/2. Now this is where you're going to go and fill in every single point on the unit circle to become very familiar, and you will not be quizzed on that. This is an exercise that I'm making you go through so that you can fully identify each of these points. These are calculator problems. You just need to make sure that the mode of your calculator is in radians. So let me show you how to do that here. Okay. So for your calculator, you need to find, let me clear this, you need to find the mode button. Alright? The mode button is right here. And in the mode button, you want to work down until you see radians. So I'm going down to radians, and then I'm going to push enter. Now I'm going to exit out, and I am going to now type in something. Like if I want to know the sine of 0.2 radians, I just type sine of 0.2, and it will tell me that the sine of 0.2 radians is 0.1986, etc. So now you always need to be mindful when you're using a calculator, are you using degrees or are you using radians? And then always check your mode button. You see the mode button? Always check to make sure that your mode button corresponds radians and degrees. Okay, so lastly I want to work through some problems from the book. So starting on page 124, number 62, the cosine of S is equal to 0.7826. To solve this problem, first and foremost, you must read the directions. The directions tell us that we are looking for S, and we are looking for it in the interval of 0 to pi halves. So S is in the interval from 0 pi halves. Now, on the unit circle, 0 to pi halves is the same thing as saying the first quadrant. So to do this, you simply make sure your calculator is in radian mode, and then you do the inverse cosine, the arc cosine, all right? So what that means is you do the button right above cosine is the cosine with a -1. That's arc cosine. So you type in arc cosine, and then you type in the value of the output, 0.7826. Arc cosine or inverse cosine will send you back to the S value between 0 and pi halves. And so that's going to give me 0.6719, but that will round to about 0.6720. This is supposed to be an approximate value, and they also in the book round to 4 decimal places. Okay, so the next problem I want to work through is number 70. Number 70 is on page 125. And in this problem, we are looking for exact values, and for starters, this is from pi to 3 pi halves. So think about which part of the circle that is. Pi to 3 pi halves means that we're looking for a value in the third quadrant. So we need an exact value in the third quadrant. And the equation is that sine of S is equal to -1/2. So what we're going to do is we're going to look for the sine value of -1/2 down in the third quadrant. You can go back to the unit circle and you'll find that the point right here, which happens to be 1 1/4 pi, or 5 pi fourths, has the value sorry, that is the wrong spot. I thought I was looking for root 2 over 2. I'm over here. Okay, this value right here, which is 7 pi 6, has the point -root 3 over 2, comma, -1/2. And that point right there, -root 3 over 2, -1/2, means that the cosine value at 7 pi 6 is -root 3 over 2, and the sine value at 7 pi 6 is -1/2. That means that S is 7 pi 6. Okay, let's do another one of these. Let's look at number 72. Oh, let's do 71. And then we'll do 72. Okay, number 71, we're looking from 3 pi halves to 2 pi. So the interval from 3 pi halves to 2 pi says that we are now in the fourth quadrant. And the equation is tangent s is equal to -1. So we want to look for where sine divided by cosine is -1. And if we go right here to this point right here, we see that this is root 2 over 2, comma, -√2/2. This is at 7 pi fourths. If you divide your sine value, by your cosine value, sine divided by cosine is going to be -1. So that means that the tangent would be -1, which means that s has to equal this angle here, 7 pi fourths. Okay, now let's look at number 72. Number 72 is from 3 pi halves to 2 pi, same interval. That puts me again in the fourth quadrant. And my equation now is cosine of s is equal to √3/2. So I want to know, where do we have that point? This value is 11 pi sixths. That angle is 11 pi sixths. Here I have the point √3/2, -1/2. I'm looking for a cosine value that's positive √3/2, and there it is. So that means that s is equal to 11 pi sixths. By the end of this homework, you should be very familiar with the unit circle. I highly advise you don't work through this homework all in one day. It's better to work through this homework over multiple days to really allow your brain time to process the information and to memorize the information. The more you can memorize the unit circle, the better. All right, lastly, let's look at number 74. Zero to 2 pi, that's the whole circle. The equation is cosine of s is equal to -1/2. So I'm looking at the whole circle, every single quadrant, and I'm looking for cosine values, x values, that are -1/2. Here's -1/2 on the x-axis. That means there has to be a point up here and a point down here. And in fact, this one right here is -1/2 √3/2, and this point right here is -1/2 √3/2. This angle, 1/3, 2/3. 2 pi thirds. 1/3, 2/3, 3/3, 4/3. So the second angle is 4 pi thirds. So that means that s, the solution set for s, is 2 pi thirds and 4 pi thirds. So there you go. And that's the end of that. Now I'm going to try to get another lecture to you soon so you can get a head start on the next chapter. We're going to be working through the graphs of the circular functions, meaning the graphs of sine, cosine, and tangent, and their reciprocals. So I'll get that posted to you as soon as I can.